Good morning and or whatever time of day, everybody. Did we get any volunteers to take notes? I think Bernard asked on.
We didn't get anyone to answer. Oh, by the way, Jonathan, I just uploaded new slides because new slides came in, so I think you want to refresh.
Okay, I'll refresh. Let me make sure. I'll be right. Do I have to reload to do that, or is there a way to do that without?
I think you have to reload it because I just.
All right, I'll be right back then.
The way you'll tell if you've got the new slides is there should be 32 of them now.
What should I see that shows that this is the new ones?
You'll see the new slides starting at slide 20.
Viewport and region of interest. No, I still have title goes here or there. So this is still the old one.
If there are no slides after 20, then you have the old deck.
All right, so it's in the data tracker. Do we have to do something to get it in the data tracker?
It's been uploaded to the
data tracker. Data tracker? Yeah, I don't know if
it might be in your, it's in your browser cache probably. You might have to clear the browser cache.
Okay, all right, let's see. Unless you want to just share them and see if it's right for you.
Well, maybe we'll try that. Hold on. Okay, so let me see if I get a different. All right.
Yeah.
Let's see. Well, okay, so we can. Well, I'll just do the.
Just share it from locally. Okay, that works.
Yeah. I don't want the whole. Okay, and let's see. What do I got here?
I think you can just mouse over on the bottom and it'll show you. Nope, that's still
the
one.
So that's still okay. So I'm still showing the old one, and I think we're going to have to do screen share. Okay.
All right.
Instead. All right.
You should be able to share just a single window.
Yeah, it's not. There we go. Got the tab here. Finally. Okay, great. All right. So now we're we're good to go. Okay.
Okay, good. Okay. And you probably want to switch that to presentation mode or whatever.
Yeah.
There you are. Yeah, great. Okay, but we still need a note taker. So I see some people who are here. Anybody care to volunteer? It's hard to have a meeting if we don't have a note taker. Ideally should not be one of the people actually presenting. So,
Spencer, are you willing to volunteer?
I mean, I think he's presenting, isn't he?
Yeah, eventually.
Spencer, I see you unmuted. I think I hear background noise, but I don't hear you.
Just be aware, Spencer, if you don't unmute, silence will be assent.
Sam Hurst is saying he can try taking notes. It'll be the first time for an IETF meeting, but he can give me. That would be great, Sam.
Okay.
Thank you. Thank you.
Great. Thank you.
So, Sam, if the ideal would be if you use, there's a note taking. See, there's a note taking tool as like the fourth button on the upper right, which will give you an online note taking, which then other people can also look at and maybe even help you with.
Yeah, I've got that open now. Thanks.
Wonderful. Thank you so much, Sam.
All right.
Okay, so welcome everybody to this interim. Hopefully you're all familiar with Medico by now, but here's the basic instructions. You will need to enable your audio manually. Pressing the button at the thing at the top left. You can see if you have audio by looking at the little. There should be a little audio meter thingy there. You can also enable video if you want us to see you. It's helpful if you want, but it's separate from audio, so you need to enable audio also. Please keep audio and video off unless you're sharing or presenting or commenting. And use of a headset is recommended so you don't get open echo. This is an IETF meeting. The note well applies. Which is basically the various IPR rules. B, you're being recorded, and C, follow our code of conduct. That's a very brief summary of something it's in itself a brief summary. Please see the BCPs and the privacy policy for details. Note really well. This is intended to be a professional environment. Please behave professionally. If you feel anyone has not behaved professionally, please contact the chairs or the ombuds team. So this is about the meeting. We have Sam Hurst as the note taker. Thank you, Sam. And here's our agenda. We're starting with ready payload format for skip, which is in IESG review, then green metadata, RTP over quick, and viewport and region of interest. And then wrap up next steps and any other business if anybody has anything else. If anybody has any comments on the agenda, do that now. Otherwise, we will move forward. Okay. Move forward. I guess. No, draft status, right? Yes. Yes. A number of things published, VEC and Cryptex, both exciting. VP9 is still in misref, waiting indirectly on frame marking. 7983 BIS is approved, announcement to be sent, which is what is that, Lisa said? Is that the AD follow-up? Bernard is the author. Do you remember was there like some, it was approved, but they still had comments, which is sort of an odd state. But
well, I think there was an IANA action and maybe one or two editorial things.
Okay.
But yeah, there's nothing really the working group worth talking about today. So. Okay.
There were some discussed positions on skip, so we'll be talking about that here. And we're still waiting for frame marking, but Mo is here, so I can nag you, Mo. Mo, please. It shouldn't be very much work, Mo. Just please get it done. So mostly so we can publish VP9. And then adopted number of things which we'll be talking about today. So that's cool. So Skip. And Dan, are you presenting? Yes.
Yep,
Good.
Dan's here. All right, thanks, John. Let's dive right in here. We had a couple of comments regarding from the telechat group and the TSV art group. Mainly the section that was missed, we failed to put in there before, the congestion control considerations. So we will be adding that into a upcoming revision. A lot of it's, again, the boilerplate text from the standard RFCs, and as well as a particular sentence basically saying that skip in itself is limited as far as basically what codec is underlying. For example, the Melpin 729D don't really have much you can do with that other than increasing the packetization rate or something like that, more packets, more video, more codec frames per packet or something like that. But so the kind of congestion control mechanisms will be kind of limited. But again, it's really based on what the underlying codec can support at this point. So it's kind of our position with that. We going to be renaming the section we had put in before, change controller address. We realized that was kind of poor choice of wording on that. So we're going to change it to skip contact information regarding specifically the skip 210 specification, which is under the control of the NATO skip working group. I think one of the commenters was concerned that that was applying to this document, the internet draft, and it wasn't. It was meant to emphasize that the skip 210 specification is under control of the skip working group. There are some other minor editorial corrections that we will be making based on some of the comments, just minor wording things here and there. But also what we're looking to do is kind of also trying to shift our focus. There's been a lot of conversations about exactly what our RTP payload format is. And we've tried to describe it as best we can without going into too much detail, only because it's hard. It's unlike other RTP formats, that there's a fixed format and there's only one format and that's all there ever is. Skip is a lot different in that aspect. It's that there are many, depending on the state of what skip is in, the stream can be different, so it's really hard to pin it down into one particular format, which is why we've been trying to avoid doing that. And I guess it's caused some confusion in some of the reviewers outside the group that have some issues with that. Again, but we want to emphasize that we want to be treated basically like a unformatted clear channel, kind of like what RFC 4040 is defined. Unfortunately, RFC 4040 doesn't meet our needs, so we can't just use that for transporting skip. That's why we're looking for our own, because it doesn't do video and it doesn't things like that. So we kind of want to be able to shift the focus on that to be, again, we'll put some revised wording in the abstract introduction saying that we want to treat this as a clear channel, with the intent of that network devices cannot or should not be able to try to profile what our traffic stream is looking like, because it's so highly variable that it would seem it's an impossible task that you'd be able to build a network filter or packet filter based on what the contents of the skip RTP stream would be. So that's kind of where we're trying to focus on that. I'm not sure what the group thinks about that, but we can certainly talk about that as a way forward with this. Again, because we've received so many comments for folks wanting to really dive into the RTP payload format, which in a way, again, I understand that's the focus of, but most typical RTP payload format RFCs do that. But again, I think ours is a special case because the format of our stream is not a fixed format like the others. So it's kind of where we are with that. I guess next slide. There was also some talk about one of the reviewers about the security consideration sections, specifically, again, the boilerplate text that refers to RFC 7202. The reviewer felt that that was irrelevant because skip payload is encrypted. We disagree only because part of what 7202 talks about is secure RTP, which goes beyond just encrypting payloads. As you all know, it has payload encryption plus authentication header, authentication mechanisms with that, as well as doing secure RTCP as well. So again, there's really no reason why we can't think you could also run skip over secure RTP if you really wanted to. I don't think there's any technical reason why you wouldn't, but so we feel that that particular security consideration sections is fine as it is. At least that, I mean, so again, for the reasons why we're stating with that. So to where that's at, I guess final slide. I think we have one more slide. I don't know if and again, just what we're doing at this point to resolve, short of, we have a version 5 basically ready to go. We were just waiting to make sure that where we were going with the changes we want to make would be satisfactory, so we don't have to keep doing revision after revision at this point. So, so that's where we are. Thanks.
So Dan, I think it might be helpful to show the working group the actual ballot positions, because I think a lot of things you're talking about here do make sense to do them, but I don't think it's going to resolve the fundamental. I don't think it'll resolve all the discusses, because, as you said, they are looking. The ISG just considered the VVC document a couple of weeks ago. And I think they're in the mindset that they're looking for a standard type RTP payload format document with, sections on the RTP payload, RTCP, and they didn't get that. So that's where I think the disconnect is. But it might help to talk through the actual ballot positions, and at least for us to discuss what the answer is to because I think obviously we know what the answer is to the ballot positions and the questions, and it might be simpler for you to just write some of that in the document, and then it's all in the skip payload info, right? Once you read that, you understand all these questions they're asking. They didn't read it because we made it non-normative, and so you're kind of in this weird position where they're missing some info, and they don't want to read the document to get it because they want to convince themselves that it's really non-normative. So anyway, I think it might help to look at the actual ballot positions and then discuss that. Does that make sense, Jonathan? Let me just try to see if we can shift to,
yeah, it helps. Well, I guess, and that's the advantage of the fact that you're sharing from
your.
So
I'm going to stop the existing share and share a new tab, which is the ballot positions. And let's see. Okay. So here are the ballot positions. Can people see them?
Yeah, I can.
Okay. So let's go through them. So we have Francesca. So that's the change controller one. And I think you've got a reasonable path forward on that one. And then, okay, so Roman, right. So Roman says he didn't read skip 210. So then, yeah, he's looking for the format, right. So he's asking, are the details entirely opaque? So Dan, I mean, once you're exchanged the keys, right, it is entirely opaque. Is that correct?
Yes, once you're in the encrypted mode where you're encrypting,
right,
any codec you are. I mean, again, there's the section establishment, which is not necessarily in the clear, it's basically clear text, if you will, but it's not,
Right.
again, referring back to 210, it's a series of messages that are defined in 210 that go through the whole process of establishing the keys and things like that. So
Yeah, I don't think you have to go into detail on the key establishment process, but as an example, if you were to say here that once you've reached the key establishment state, which is where you would be once you start, once you reach that state, then it is entirely opaque. I think that would address Roman's first question.
Mhm.
And then
Okay.
I think that can help you. The other thing I think you need to say as far as the RTP format is concerned is that because SCIP is essentially dealing with the underlying codec, and I think you do say a little bit this, but maybe not altogether in one section, which is that essentially the underlying codec is doing the packetization, right? So whatever it happens to be, H.264, so the H.264 is, figuring out where the now unit boundaries are and so forth, handing that to the encryptor. So essentially the packetization is being done by the underlying codec.
Correct.
So when he's trying to figure out,
right.
right, he's trying to figure out what ends up in the payload, the answer is the underlying codec basically passes up does it according to the existing RTP format, payload format document, passes that up to the
or by
encryptor.
something proprietary to skip, and that doesn't matter. Yes.
Well, the only part that SCIP plays in that, Jonathan, I think, is
Oh,
just
I mean, we don't. I mean, they might be doing something different than what RTP payload format does, and that's fine because it's not our business, effectively.
But Dan, I think you say that it is doing the RTP format elsewhere in the document, right? Is that always true?
Yeah, we talk about that it's, it's basically
Yeah.
using the existing, 729 or whatever, 711s,
Yeah.
things like that,
Or
those codecs.
H.264 or whatever it is. So
Right,
it's that packetizer which is passing this stuff up. SCIP just then encrypts it with the keys that it's derived. So anyway, that's the process by which the RTP payload field gets filled in.
Once,
No.
right, not counting the session establishment process, which is
Yeah,
our
you
kind
don't
of
have to go into that,
which is
but
our
just
sticky
say,
wiki part of that.
Yeah.
So.
Yeah, you don't have to go into Z, but the point is that once it reached key establishment state, that's how it all works. So anyway,
Correct.
if you were to describe that, I think that would address Roman's first question, and then well, let me look at the second one.
Again, that's a security consideration section. Again, he's
Hmm.
commenting on
Right.
the boilerplate text that is the standard security consideration
Yeah,
section.
so I think that one. Just trying to understand what you could do there. Well, it appears there's tight coupling. Yeah, there is, I guess. But the point here is you reach the key establishment state, and that's really all you need to know with respect to RTP, because there won't be any RTP exchanged. Well, I guess you're exchanging the skip messages within RTP, and once you reach key establishment state, right, then after that, that's the codecs only appear at that point. Otherwise, you're just taking the skip messages. I mean, I guess you may need to say a little bit about how you the skip messages prior to key establishment state are just essentially they're essentially fragmented into the RTP payload, right? With the marker bit telling you at the end of a particular message. Is that correct?
We aren't using the marker bit for that. So it's just.
So does each message fit within a packet? Is that right? Or is it just a bit stream with its own marking? Just trying to understand how
it has its own message length and fields in it, which tell you how big it is. I mean, some of them may span multiple packets because they may be bigger than the MTU size.
Okay. So that's all you need to say about the skip exchange prior to reaching key establishment state, right? That's the part of the RTP payload that just describes how the skip messages get sent. There's a length field. That's it. So that anyway, I think those two things would address Roman's comment. So then we have
So I mean,
Magnus.
do you think that, I mean, keeping that section in is fine? 'Cause,
Well,
I mean,
it just,
again, I think that's what that's required, isn't that in most RTP payload
well,
RFCs, to
so
have that security consideration section?
yes, keep the security consideration section. I'm just saying, if you were to put that stuff we just described into just create a little RTP payload format section and just put what we just talked about in there, I think that would,
Okay.
that would give Roman what he needs to understand the payload format. It's not, what we just talked about is just a couple of paragraphs and that's it.
Right. Okay.
So then, because then they would have the section they're expecting, and then they would go, I have it. Okay.
Right. Right.
So then let's talk about. Okay. So then we have a comment from. Okay, another comment from Roman. Okay. Then he's talking about secure session establishment protocol behavior, which I don't. Again, you don't have to go into any more detail, I don't think, except what we just talked about. I think that would give him what he wants. And then, okay.
These are some of the editorial things or whatever.
Yeah, these are just editorial, right? Okay.
Yep.
All right. So then we have Sarker. That's RTP profile. Well, that's right. I mean, with most codecs, right, you can. The answer would be it depends on the codec, right? I mean,
and the
Yes.
architecture you're dealing with, yeah.
Right. So, but that's again, skip is just encrypting whatever codec you're using. So, I guess maybe that's not clear enough that there's this underlying codec that's going to determine that. Yeah. So maybe a few words early on, Dan, just making it clear that skip is just encrypting underlying codecs, and so the underlying codecs determine the answer to these questions. Does that make any sense?
Right. Yep.
Yeah.
Yep.
And then traffic is highly variable, right? Because it's the underlying codecs again. What is highly variable traffic? Well, it's this concept that the underlying codec is the underlying codec, right? Which could be audio, could be video. That's what you mean.
Right. And it's, depending on what its state is and how you can adjust it or
Right.
not adjust it based on.
Yeah. So maybe
RTCP.
Right. So maybe that's. I think the thing that they're missing is just the overall concept that we just talked about, which is that there's underlying codec and skip just encrypts it. And yeah.
Excuse me, this is Mike Fowler speaking. Can you guys hear me now?
Yes, we can.
Yeah.
Okay, I haven't been able to be part of this from the beginning due to technical problems within our company here. I would like to. We use the term codec, throwing it out there a lot.
Right.
That underlying codec can be something as simple as a chat session too. So
right.
We need to understand it appears more like data than it does necessarily a codec going across there. It is just whatever skip happens to be using it for.
Yeah, because technically skip is the codec from this SDP point of view. So yeah, that might be confusing them a little too, but I think the point we're trying to get across is that there's an underlying encoder or decoder, and that's maybe a diagram would help feeding it up to skip that's encrypting it. I'm not sure, but that's why I think that's what I think people are stumbling on here. Yeah, I mean, you're not the bit rate again. Well, you say a jitter buffer may be implemented. Well,
yeah, I think I think that might just be a matter of wording. I think what you mean is it can only be implemented in a endpoint device, whereas he's interpreting that as the endpoint. The endpoint has the option of not implementing a jitter buffer, which I think is not true.
Right.
So yeah. I think that's probably just an editorial thing, and it needs to be, only I think it may just say only an endpoint device can usefully implement a jitter buffer. Would be,
good point.
More or less what you want to say.
Okay.
Okay.
So I think between those, yeah, I think I think Sarkar's comments can be resolved with that way. And let's see. So he also asked for a link to skip spec, which I think is easy to provide. And yeah, well, Sears, he's saying he's looking for the design principles. And I think that's some of what we've just been talking about. I don't think you need to go into skip in infinite detail here. I mean, the way I think about it is like in IPsec, right? We have the division between IKE and the IPsec format. This is the equivalent of the IPsec format. So you wouldn't do a bunch of stuff about IKE in an IPsec document. But you just need to know a few things about skip for this all to make sense.
What would you think you need to know about the skip to implement that?
Well, the only things are only relevant things are the things we just talked about, which is that you have this exchange of skip messages. You're going to describe how they're packetized, and then you reach key establishment state, and that's when the data that you call it will start to flow. So that's,
I think
right. That's really all you need to know. If you want the state machine, you go read the skip document, but you don't really need to know that here, I don't think.
Right, that was kind of the point of the email I sent. As the truth, you don't need really to know skip 210 to open
Right.
a payload type for skip and let the traffic flow. It has
I think it's it's more, it's not so much a matter of what an implementer needs to know as what the document reviewers need to know here. So basically, is what they need to know to understand whether this, does this make sense? And because we've told them that that skip is informative, they want to know this without reading the skip document.
Yeah, I mean, like when I read the skip document, I understood all this within the first couple of pages, and then I didn't have the question. But because we want to keep it non-normative, I just think you just have to have a little bit to just give them the framework. And you can say something like the skip document creates a state machine, but basically the only things you need to know is there's this exchange of key establishment, messages and negotiation, and then you hit the key establishment state, and everything is a big blob after that.
Yeah, throughout the session, it can change. It will be very.
That kind of doesn't matter. I mean, that's sort of more. That's deeper than you need to say here. Just sort of in a very high level detail of, just give the 30,000 foot view of how skip works so people know what's going on.
Yeah, I mean, you can have, key renegotiation or something. That's fine. Again, that goes back. Yeah.
Application change.
Yeah.
All that can go on.
Yeah. Again, I mean, it's not gonna. I don't think that really. I don't think they need to. You can say that that'll happen, but it doesn't really affect unless it affects.
My opinion, the less said, the better, because it doesn't necessarily even have to go through the type of things that were originally discussed. It can just start up into traffic mode in a particular mode. You don't have the messaging, so the variability of this. One of the fears that I've had in speaking with vendors of network equipment is when they first hear this, the comment, the first question out of each of them, phrased differently, was how can I filter on this? And the truth is you can't. It's just that variable and changing.
Yeah, well, I mean, I think I think a 30,000 foot view that makes it clear that it is variable and changing would best be useful here to make clear to people, that trying to filter on it is a fool's errand. Don't try. So basically, just give enough description to say, this can be in any number of different things. Don't try to filter on it. Would I think would be helpful, both for the explaining to the IESG what's going on, and also for implementers to know. Don't try to be too clever.
Well, implementers of skip will know what to do because they'll be in.
No, I mean implementers of network equipment that have to pass skip.
Yeah, I mean, the IETF has had huge numbers of problems with people doing deep tech and inspection and expecting certain things, and then when the version changes, the equipment starts breaking stuff. So you're in good company here. I mean, that happens a lot with many different
That's what we're
things.
trying to avoid.
Yeah.
Right,
So
right.
yeah.
And give us an RTP channel and we'll work through it. We
Yeah.
don't
Yeah.
care what you do
Mm.
in your network devices between your RTP there. And we
Yeah.
implement RTP in our endpoint devices to best
Mm.
practices, but they are vendor specific. Each vendor is implementing their own product to their specifications that will work on a network. And we have to be careful not to put things in here that make people believe or expect certain things
Yeah.
out of devices when we don't control that.
Yeah.
Yeah. So I think you need to make it clear, that make it clear that any number of things can happen. So don't try to be too clever. I think that would be a useful
Yeah.
documentation here.
So I mean, if you look through, Dan, for example, in the quick specs, there's a lot of concern about what they call ossification, which is a similar thing. People expecting quick to look like that, and then the version changes, and they're afraid it'll be broken. So you could include a little section within security considerations, for example, on deep packet inspection or this kind of profiling, just to make it clear that that's a fool's errand.
Well, that's a good place to put it. That's a very good place to put it.
Yeah,
Yeah.
just don't do that. So anyway, I think if we keep to what we've just been talking about, that could be a path forward to get past these discussions. Just basically put in the minimal amount of info that the ISP needs, that they would get if they read skip 210, but they don't want to. So
Well, we try and point them to RFC 4040. I don't know if you guys discussed that or not.
No, I'm not. I mean, and it's
yeah,
I mean, it's often the case that it'll be different people at different times, and obviously that was an entirely different IESG at that time, and sometimes they're like, well, just because they did it 15 years ago or whatever doesn't mean we agree with them. But that's a pretty common phenomenon, unfortunately. But
yeah, it was the model of what we were looking for.
Yeah, I mean, I think it's a good model, but you might need more explanation than they insisted on that,
right.
which is fine, I think.
Our task was to basically create a similar model to that we would get through. And if we start adding, we have to be careful on the impact to the skip community, which is diverse at all NATO nations, basically, plus their partners.
Yeah. I mean, I understand that you don't want to create conflicting normative text or anything in the two documents, but they in BVC, RTP payload, and many other things, you basically have this little summary in the beginning that kind of tells you the features of the thing of the codec or whatever, and that little section is often what orients the reader. So I think that's what they're looking for.
All right.
All right.
Okay.
Thank you.
All right. So we're now on to the green metadata, I think. Yang here.
Okay. Thank you. Can you hear me?
Yeah.
Okay, good. So yes, this the RTCP message for green metadata is proceed to the WG draft. So next slide, please. Just quick rewind. So the draft proposed two RTCP message. One is the temporal spatial resolution request. Another is the temporal spatial resolution notification. Next slide, please. So the main update in the WG draft is based on the comment we received that the spatial temporal adaptation should collaborate with the SDP update. So a new section 6 SDP definition is added to the draft to define the RTCP FB attribute and parameters for the proposed message. So this is along with the RFC 5104. So a new TSRR value is added to the CCM parameters. And some example is given to show how the capability exchange is used TSR in this case. So that's the main update for the WG draft. So yeah, that's all. So any comments, questions?
Trying to remember, I think there were comments on the list, and I think. Do you remember that, Bernard? I'm trying to. I think.
Yeah,
we have to go back over the list.
Yeah, there's comments received from Nokia that it should note how the SDP may be used in this case. Yeah.
Let's see. Yeah, let's see.
Maybe I can copy the message to the chat window.
Yeah, I'm just reading very. I think the other question about Nokia is I think a matter of if there was any discussion of if there was any negotiation of the resolution in SDP, how that interacts with these messages. And I think the answer is probably it's you have to you should never go above what you get in the SDP, but this is not required dynamic renegotiation of the SDP as long as it's within the window SDP allows. Leave my suspicion, but probably you should say that. There was also a question of, I think, from Magnus Westerlund during the call for adoption. I think about the format, which maybe you should take a look at. This is on November 23rd.
Yeah, there's other comment received, but most were addressed in last meeting. The only comment is how to rename the title. Yeah, I sent the question on the reflector. I did not receive the preference, so I just keep the
okay, yeah. I mean, as an individual, I would certainly be, I think it would be clearer what it's about if we just said it was temporal spatial resolution. Especially because the green metadata document from the whatever group that was that did that, MPEG did, it does more than just TSR. It does a number of other formats also. So making it clear this is just TSR, and that for people who are not familiar with MPEG, that it's TSR, I think would be helpful. And that's an individual opinion. So if anybody else feels differently,
okay,
I think this would be yeah. Okay, is that all? You want any other slides, or is that all? All right. Any other comments on green metadata? Otherwise, we'll move on to RTP over quick. Dale, did you want to say something, or are you just unmuted?
Oh, I'm sorry. No, I don't want to say something. I just need to do it to get my speakers to work.
Oh, you have that bug where it's not working in the. Yeah, there's a. So sometimes Metaco is weird, and so because it uses two different modes, and sometimes one of the modes doesn't work. That's fine. All right, who's presenting for RTP over quick? Is it Spencer?
Can you guys hear me okay?
I can hear you, Spencer.
Okay.
I see both Spencer and Mathis unmuted. Which of you is presenting?
I will start, and then I will hand over to Spencer.
Okay.
Yeah, and Mathis is starting. I was making sure that I could unmute when it mattered. Sorry.
Okay, great. Yes, no, thank you for doing the sound check before, we all stood around and said, hey, how come we can't hear Spencer? So, yes.
All right. I think you can hear me too.
Yes.
So great. We have a short update on a new submission we posted this week, and then we will go over what we're currently discussing with Spencer and Jörg, and in the end see what other open issues are upcoming. For our new submission, which we posted this week, we rewrote the abstract and restructured introduction. The introduction has now a subsection on background, and we have 2 new subsections on what is in scope and what is out of scope. Then we added new terminology points for congestion control and rate adaptation. We will go into a bit more detail of congestion control later. So these terminology parts may change, but we added them for now to have a start. Then in the last interim meeting in December, I think we discussed multiplexing a lot, and then also on the mailing list. We now added a new subsection on that topic in the draft, and that subsection continues to use the flow identifiers we had before and adds more explanation on how that works. Then we made a couple of clarifications on the RTCP feedback packet fields that we map to quick state information in the RTCP section. And we had a couple of editorial changes throughout the whole document. And we added Bernard, Sergio, and Vidi to the acknowledgements sections. Thanks to you again for providing feedback and issues. Next slide. So for congestion control and rate adaptation, I briefly mentioned we have new terminology on that. We got the feedback that the whole section on congestion control, as we have it in the draft, needs some more work and needs some clarifications on a couple of questions. So for example, we obviously have the question of what kind of congestion control should be used, because RTP obviously prefers low latency rate adaptation, while some quick implementations may only provide byte transfer optimized congestion control. Then that also leads to the question which layer should actually do congestion control and how do they interact if we have congestion control at the quick layer and at the application layer. And then since we already had it before, but now we made it explicit in the multiplexing section that we can have concurrent non-RTP streams, we of course also have to care about congestion control between or sharing bandwidth between non-RTP and RTP streams. Then from here, I think I'll let Spencer talk about what's the current state in the whole discussion. If you want to join in, Spencer.
Yeah, thank you, Meredith. So where we are so far is that we've had some good discussion in GitHub and on the mailing list. We especially appreciate the review that Vidi did and her engagement with us in GitHub. I've managed to convince myself that there are multiple issues in GitHub now, but that those issues are not complete and may not be all that well structured, which I get to say because I wrote them. There are also suggestions that we're talking about that are kind of contentious, and I can go into more detail about that, and maybe it would be good for me to do that. But just, like number one, if there are things that we are going to have to do or have to not do, then that can constrain the rest of our conversation, if that makes sense. Meredith, is it okay if I talk for a minute about the congestion control controversies?
Yeah, sure.
There are far too few people in line at the mics already. So one of the things that we've talked about periodically for a while is disabling quick congestion control. The issues I've seen with this over the past number of years that we've talked about it, any implementation can do anything it wants at its end, but there's not a defined way to tell the other end to do that. So how do we make sure that we're talking to a other end that will do the right thing? That could be port numbers, which some people don't like. That could be ALPN, which some people don't like. There we could just assume the RTP sender will never cause quick congestion control to kick in because it's interactive media, and just think happy thoughts. And there could be other ideas as well. I feel like I should be looking at Zulip while I'm talking. The question of what we would need to do to conform to RC 8085, because we're running over a UDP, and if we're turning off quick congestion control, however that happened, that it would be that we need to figure out what our own congestion control story is, because we're not running over a congestion control transport.
Bernard has put himself in the queue, presumably. Yes.
Okay, Bernard, tell me when I should stop and let people talk.
Yeah, no, I'm just. Yeah.
Yeah, I guess my
could be now.
My comment was two things. One of which is that I don't think you need to negotiate congestion control, right? The quick protocol, as long as you conform to that, lets the sender choose congestion control mechanisms. So it's not something that really needs to be negotiated, and both sides don't need to use the same thing in each direction. And it won't cause an interrupt problem. It might cause other issues, but so I don't think you have to really get into negotiating it. With respect to disabling quick congestion control, I mean, we've talked a lot in various venues about figuring out what algorithms would work. And, if the document has recommendations, that would be great. But is there really serious discussion about people just disabling it and doing away with it? That's certainly not going to work in environments like a browser, right? You pretty much have to have something there. And I don't know, is that a serious thing that people really want to do?
So I would say three things, and one of them is that Mattis is also in the queue, so he might want to correct me on this. I think there's two levels of this. One is we're using the language about disabling quick congestion control, but the other question is how do all the entities in an implementation know who is doing congestion control, who is doing rate adaptation, and how do they know that they're doing rate adaptation that is not for H3, not appropriate for H3. So if we could not run this over BBR that is going to do bandwidth probing and then lose packets as it's figuring that out, that would be great. So the question is, how do we know that we're talking to an other end that will do the right thing? If I'm asking it to send something, how does it know how does it know? And whether that is at the quick level or at the RTP level or at the application level, that's an interesting story. Bernard, did that help?
In the case you just mentioned, Spencer, it's possible for one side to do BBR, the other side to do new Reno, right? They can still talk to each other. The draft can certainly, as you mentioned, the probe RTT phase will mess things up. So that probably wouldn't be a great thing to do, but they don't have to signal each other about what they're going to do. Each side can decide its own congestion control. It's not negotiated. And I think the job of the draft is to kind of describe what is likely to lead to good results.
Okay, and that's fair. What I'm saying is I'd like for us to adopt what you just said as a thing going forward. And if that's not the right answer, we can argue about it on the list. or in the right place. The third thing was whether there was whether we should have a mandatory to implement rate adaptation algorithm. And I don't think we should for some processy sort of reasons and some technical sorts of reasons. But I don't know that we agree. I don't know that we agree on that. I don't know who is looking at work that Christian Wiedema is talking about in Mach, like in the past week or so, for a media aware congestion controller. So it may be early to pick an algorithm now, but the other thing I thought I knew was that a lot of the work for NADA and SCREAM was making sure that they were safe against other NADA or other SCREAM. I don't know how much work was done on them running against other congestion controllers. And that would be the kind of thing that bringing them into the IETF and having the IETF review them for publication as proposed standards or whatever it would be. But just basically, how do we get the IETF review of those that would justify putting them in this specification as basically a must implement? Again, I'm not saying we should do this. I'm saying this is the kind of conversations we've been having. I should be not starving the queue now. So let me
Peter's up
start
next.
with Peter. Oh, where did Peter go? Or is Peter talking?
Peter's unmuted, but I don't see him. I don't hear any audio from him. Peter, are you sure you have the correct microphone or whatever on your end? Oh, Peter made some comments in the
Okay.
Yeah,
In
the chat.
Can you hear
in
me
the
now?
chat.
Yes, we hear you now, Peter.
Peter,
Perfect.
Yeah.
Perfect.
So I don't think this is a question of whether or not we're turning off congestion control in Quick. How an RTP over Quick endpoint implements the combination of Quick and RTP on top of that, I think is an implementation detail. And really what we're asking is, what is the feedback it's going to use to implement that? And so the question is whether the feedback is in Quick or the feedback is on top of Quick. And just like in the WebRTC world, we don't standardize which congestion control algorithm use, but we do try and standardize feedback mechanism.
right.
We should be talking about what is the feedback mechanism. Are we going to extend Quick so that it has the timestamps necessary on the feedback already there so that you can do proper congestion control? Or are we saying, we don't want to try and extend Quick, instead we're going to do it on top of Quick with feedback that's embedded in streams or datagrams? I think that's the real question. How a particular implementation uses that feedback is, I think, up to the implementation.
Peter, thank you for that. I agree with that largely with the thing that I'm curious about, which is if an application, so there's really, a lot of the, like I say, I want to improve, back on my slide, I want to improve the quality of the discussions that we've been able to have by having better issues with better descriptions. So one of the things I'd like to do is we've had a lot of conversations as if there were two levels, but if an application on top of RTP is trying to do this also, there's really three. And we haven't had a lot of conversation that focused on all three. We've had conversations that focused on two of them. So that's and especially taken with your comments in Zulip. That's super helpful. I should also mention that Harold had a useful comment in Zulip as well. But let me go. Like I say, let me go back to the queue and Jonathan.
Yeah. So I think, on the topic of the congestion control, I mean, I agree that the question of whether you have congestion limitation, whether congestion control at the RTP level. I mean, I think, let me put it this way. I think the decision of what to send, basically the decision of how much, how much is available to send has to happen at one of the transport stacks, which is a separate question. But the decision of what to send obviously needs to be at the application level, whether that's adjusting a codex encoding rate or, a SFU doing something like scalability considerations or whatever. But I think yeah, that probably does need to be clarified. The other question on the CC, so my expectation, though this obviously needs some experimentation, is that if you're looking at a standard FLOSS-based or Q-building-based congestion algorithm like Neurino or Cubic, if you then run a low delay congestion algorithm like Google CC or NADA or whatever on top of that, my expectation would be that, except in extreme circumstances, the lower level algorithm would never cut in because you're keeping your queues low, except in like extreme, like you have a sudden drop in available bandwidth case, which so my expectation would be that those would actually work together well. Things like BBR2, as I said, might be more problematic. And it's not really clear to me how things like L4S would interact, because I don't have good intuition for that yet. But it might be that they would, again, just not interfere with each other very much. I think the issue is not so much centered. Again, I think all these are things that can be done at one endpoint. So the issues are then communication between the layers, which, if you're talking about things like web transport, is a matter for standardization, though not necessarily IETF standardization. Otherwise, it's just advice to implementers, basically what kind of APIs you need to have available and what kind of features of your quick stack you need to have available. Both of those things are useful in the document, but with different levels of normativity.
Right. So, like I said, the high order bit on this, from my perspective, was basically asking people, don't go look at the issues that are out there now. Let us clean them up between now and IETF 116, so we can have a coherent and well-structured conversation. And then, like I say, give us a hard time at 116 if what we have done is not that.
Okay. Bernard?
Yeah, I just have a general comment. I've been playing around with this for a while, and one thing I found is where the rubber hits the road, Spencer, is when you're sending a keyframe, because your keyframe will be 10 times or more the size of the P frames that you're sending, and so that's where you can start to get yourself into trouble, because you can talk about average bit rate, but it really doesn't mean all that much when you have this spike around the keyframe. And so that's where you kind of have to make the decision, based on your feedback. What am I going to do? Am I going to lower my resolution or change my QP or something, because I've been having some loss. So that's where it really becomes a problem. And there's two things that you need to know. It's there's the bit rate available, a bottleneck estimate, that's useful. But it is sometimes not enough information when you're talking about a keyframe, because it can be so big. So it's not just it's you need to know. one thing which actually I've seen is useful is to know the size of the congestion window. And in particular, what that tells you is how many round trips it's going to take to send the keyframe. And so that actually can turn out to be a big delay parameter, because it, depending on how big your C wind is, it could take like 3 or 4 RTTs just to send the keyframe because it's so big.
Right.
So anyway, you know, we've been trying to work through in the W3C, for example, what information that the application would need to know to start adjusting the encoding parameters.
Right.
And we don't really have implementations, so we don't know whether they're good enough. But I mean, Peter's been doing a PR on try to bubble some of that information up, so that when it comes time to do something, you'd have the information you need to decide what your best option is.
Yeah, and that's very so. When I showed up and started talking to Madison and York, this is exactly the kind of thing we're talking about, which is basically the other thing. Bernard, tell me if you agree with this or not, but it seems like we're going to have an arms race between people wanting to send more and people having better compression. And and so the thing with what you're saying about the very biggest frames that we send, I would not be surprised if they were getting bigger over time. If, at least until somebody comes up with a way to adapt to that.
Yeah, because there's two things you can do when you get better compression, right? You can keep the resolution and frame rate the same, or you can decide, hey, this is cool. I can do higher res and do more sophisticated stuff, and maybe make a better AR/VR system or whatever you're building, right? And so just having better encoders doesn't necessarily mean you end up sending less, because you could just take on more, try to make it more sophisticated.
Oh yeah, I mean, is this even a question?
Right. Yeah, it depends on your application, right? And as you said, sometimes, like for example, for AV1, which we've been playing with, you'll see the P frames can be very small, but then if you're doing even if you're doing high resolution, with a talking head, but then you send the keyframe, and the keyframe is going to be 10 times that size, so it's going to still be pretty big. Could be 60 kilobytes or something like that.
Yeah, and Manus and we're doing the due diligence and basically trying to see if quick congestion control was kicking in at all on some sample traffic that they were looking at, and it wasn't. But I mean, the question is, how long can we get away with just thinking happy thoughts about that? They did the right thing. I'm just saying, we need to keep an eye open.
The other thing, Spencer, that turns out to matter in all of this is the amount of concurrency you want. So, for example, are you sending P frames at the same time you're sending the keyframe?
Yes.
And that's important, because some people are saying, hey, you're dragging out the keyframe transmission time, but the glass-to-glass latency could actually be decreased by having that concurrency. And the second thing that the concurrency does is it actually influences the C wind and the growth of the C wind.
Yeah.
So anyway, that's just something for people. That's another parameter that you have to play with, is the amount of concurrency.
Yeah. And it is something for people to think about while we are cleaning up the issues in GitHub. If I could just mention a couple of a thing for our note taker. First, I will cut and paste my notes of what I meant to say about the congestion control controversies in the notes, so you'll have that to work with. And just in general, it's really helpful to have the discussion in now Zulip as part of the notes, because often that's where the real meeting is happening. So back to you, Metis.
Yeah, sure. Next slide, please. So after congestion control, we have a couple of more issues, which we grouped into 3 here. It may be a bit optimistic to say we will discuss all of them in IETF 116, but that's what's the plan for now, to work on these after we cleaned up the congestion control issues. Then we have 2 issues on quick multicast and quick multipath, which we think may be rather to be solved in a follow-up document, because those are themselves still work in progress, and we're not sure if we will be able to solve or say anything about these in the current version of RTP over Quick. And then I think in London, we had a discussion about S-frame and S-packet. Depending on what the solution there will be, if there will be some more general solution which also applies to other things outside RTP over Quick, we might only reference that from RTP over Quick, or if there won't be anything like that, we may say more about this. So at least for now, I'd like to defer the discussion about SRAM and S-packet and see if we have anything after we solved all the other issues that are listed for next steps. And yeah, I think that's it for an update for today. Any questions?
Spencer?
Yeah, I was just going to observe that Metis has a great point, which is if people want to help with this between now and 116, the issues on slide 19 here are great places for people to look at and provide comments and feedback, maybe even text. Definitely thank you for that. Also, the text in the scope sections, what's in and what's out of scope, especially, but section 1 is pretty heavily rewritten. And if people look at that and see things that they don't agree with, please let us know, because that's kind of what that's kind of the scope that we think we're working with. But thank you.
Spencer, do you want to solicit volunteers for working on some of these issues?
Technically, Metis is leading the charge on these. So okay. On 19, I will be back for a list of volunteers on the previous slide in 116.
So if there are volunteers who want to work on these, that would of course be great. I think 45 was already discussed in London. We don't have a final solution for that yet. We should add some text for that, but there were some details why I didn't do that yet. And then the others, of course, if there are volunteers, I'm always happy to have feedback on these or even help people to write text. And of course, also on the congestion control issues, which we discussed earlier.
V says I can work on congestion control issues in the chat. Otherwise, I mean, it's not a huge outpouring of volunteering, but maybe people are just being shy. So let's move on. And Srinivas. Srinivas, I see you unmuted. Can you talk? Make sure we can hear you.
Hello. Thank
Yes,
you,
I hear
Mr.
you.
Can you hear me? Okay, thank
Yes,
you.
we can.
Thanks for accommodating our request. We recently submitted the viewport and region of interest dependent delivery of volumetric media proposal document. And thanks for accommodating for this interim meeting. In this, basically, I provide a brief background on the immersive media and the motivation behind the proposal for the partial delivery of immersive media, and then add a few details about what our proposal document is actually providing. Can you go to the next slide? Hello. Yeah, thank you. So there has been a substantial increase in the interest towards emerging media technologies such as virtual reality, augmented reality, and other immersive experiences. It's majorly because the visual volumetric media increases the end user immersion compared to the traditional 2D videos. And majorly an example for such kind of immersive media is a point clouds, which basically stores a set of data points in the space or belonging to a 3D object. And the number of basically the data required to store these point cloud objects is enormously high, because we have millions of points in dynamic point clouds, and the number of bits required is pretty high. So MPEG 3DG working group has developed a video-based coding standard V3C, video-based visual volumetric coding. And we also have an RTP payload format for transmitting the V3C coded data, and that was submitted into the AVT core working group, and it's currently in the working group stage. It's been provided the details in the slide. And there are also plenty of XR use cases that are basically discussed in various standard bodies, such as AR conferencing, shared AR conferencing experiences, streaming volumetric media to glass type MR devices, and other stuff. So basically, the motivation behind the contribution is because the bandwidth requirement for the real-time transport of this immersive media is so high. So the need for support of partial access and delivery of the immersive media content based on the user's viewport or region of interest is very important. So to enable the partial access, basically a volumetric video frame can be divided into a number of independently decodable tiles. So we call that as a 3D tiles. And this basically, all these decodable tiles are mapped into a 3-dimensional subdivision of the space. So as shown in the figure, basically the 3D regions are axis-aligned cuboids, which were basically defined in the Cartesian coordinates with an anchor point and the size of the cuboid. So a volumetric video, that a volumetric image that was framed, that was shown in the left side, has been partitioned into 3D spatial regions. So can you go to the next slide? So obviously, during the real-time transmission of the immersive media, the 3D spatial regions that we can define basically need to be transmitted to the receiving side, and the receiver can request for a portion of the immersive media content based on the region of interest or a viewport-based request. So if you take the based on the region of interest, it can be a static 3D region, or the receiver can request for an arbitrary 3D region. And in case of viewport, like based on the current user's viewport, it can request for a viewport-based delivery of the content. And obviously, when the sender receives the request for that, it basically constructs based on the 3D tiles that are present in the spatial region, and it constructs the actual 3D regions that needs to be transported. So it's essential for the sender to inform the client what are the information, or to report the client that, okay, the region of interest information that has been provided to the client. So the client uses that information, and basically when the user's viewports are changing, it can based on that information it can respond back. And sometimes the 3D, the immersive media content point clouds, the spatial regions are so dynamic, so they will be changing over time. And in this case also, reporting this dynamic spatial region information is very important from the sender to the client. Can you go to the next slide? So considering all these things, so the problems that we have is like how to signal the spatial subdivisions that are defined and that can be used for partial access. So how do we define those subdivisions, and how do we share it with the client is what is the problem. And also when when a receiver knows about the spatial subdivisions, how can it actually retrieve the content based on its viewport or region of interest and other stuff? So how can it be achievable? And also how the sender can inform the receiver about the changes in the spatial region during that over the time. So and basically all these cases, so the required signaling between the endpoints to negotiate the mentioned capabilities is also need to be solved. So to resolve all these problems, we have actually proposed the document. Can you go to the next slide, please? So we have various proposals. So we proposed like RTCP feedback messages. So the RTCP feedback messages can contain a request for a static 3D region of interest or an arbitrary spatial region of interest, or it can be a 3D viewport. So when a sender receives this information, this feedback information from the receiver, then it basically prepares the content for that particular spatial region or viewport and reports back that, okay, this is the spatial region we are transmitting, or if there is an update in the spatial region, so the sender basically updates the client saying that these are the dynamic 3D spatial regions present in the content. So this information can be transmitted using the RTP header extension for real-time transmission cases. And of course, all these capabilities needs to be negotiated between the sender and the receiver using the SDP. So the SDP signaling for static 3D regions needs to be done, and the RTCP feedback messages that were discussed earlier, and the RTP header extension formats for the above cases needs to be resolved. So we defined all those things in our proposal document. Can you go to the next slide, please? So for signaling the above mentioned information in the SDP, we defined a new media attribute called equal to 3D regions. So it basically informs the number of 3D regions present in the content and what are their positions and the size of the 3D cuboid and other stuff. And we also have some information about like, oh, okay, this 3D region belongs to what portion of the immersive media content, something like that. And also define the RTCP feedback messages for requesting static or arbitrary or a 3D viewport, all those stuff. And also reporting reporting a transmitted 3D region information, or the RTP header extension has been defined here. Can you go to the next slide? So I'm just providing an example view of the RTCP feedback messages. So we are basically using the RFC, that was RTCP feedback messages that were defined using the RFC 5104. So because these are like payload specific for the immersive media content, so we wanted to use the payload specific feedback message payload type for this RTCP feedback messages. And the FCI for this RTCP feedback messages for requesting a static 3D region is like on the top figure, and for an arbitrary region can be in the below figure. Can you go to the next slide, please? And the RTCP feedback message for requesting a viewport is provided here. So basically the viewport can contain the position, orientation details, the horizontal, vertical FOV, field of views of the user, and clipping, the near and far planes for the things. Can you go to the next slide? When the sender receives the request, so it has to basically prepare the content and also inform the client that what does the regions, 3D regions that it is been sending. So in case of like a static 3D region request, it can basically accommodate like what are the number of region, how many regions it has been sending, and the region IDs. And in case of like a arbitrary spatial region request, so it's basically the sender is constructing the data for that specific spatial region. So it basically it accumulates the number of tiles present in those spatial regions and finally send those tiled content. So in that case, basically it is constructing a spatial region for that particular request. So we can send the sender can send the position and the size of that constructed 3D spatial region. And can we go to the next slide? In case of dynamic 3D region, also it's more or less the same. It is just reconstructed at that point. So in case of dynamic 3D regions, basically the sender is updating all its 3D regions, the 3D spatial regions. So it has to be informed to the client. So the client, when basically request based on the region or based on the viewport, it will know what are the spatial regions that needs to be there. So that information can be transported using the RTP header extension. Yeah. So can you go to the next slide, please? So these are the basic messages, RTP and RTCP header extension. RTCP feedback messages and the RTP header extension messages, as well as the STP parameters that we defined for requesting these. So we're looking for any suggestions and for feedbacks, and I'm not sure. I think we can use the IETF mailing list for providing any suggestions and feedbacks. And we will update the draft based on the feedbacks we get in.
Okay.
Yeah, thank you.
All right. Are you asking for adoption at this time, or are you just letting us know about the work
we are
that's
just
going on?
letting us know about this.
Okay.
Yeah, and we are actually looking for suggestions and feedback on this.
Okay. Yeah, I mean, I think from the RTP level point of view, speaking as an individual here, the architecture looks good. I know nothing about the content of the data. That's not my area of expertise, but sort of from the architecturally, it seems, from the, use of header extensions and feedback messages, it seems reasonable. But like I said, I don't know whether the data that's being carried is the right thing for this. Spencer?
Spencer is often confused about a great many things, but is this AVTCORE RTP V3C00?
No,
Yes,
this is a. No, this is not.
No.
No, this is. Sorry, go ahead. This is that's the draft that's what we've adopted for sending the encoded.
Okay, thank you. That's
yeah. So
Spencer,
yeah,
this is a different draft for requesting which volumetric data you want.
Okay, thank you.
Yeah. So yeah, the RTP payload format is a different draft, and this basically we wanted to add on top of that. I mean, it's like utilizing those media format for payload format.
So, yeah, I guess, yeah, I think this is, obviously useful, necessary work as part of a whole, the infrastructure, I'd say if people have any comments on it, let them know, but hopefully. And so is this something that people are actually already looking at doing interop with, and multiple people working on implementing this and want to usefully talk to each other?
Yes, actually, this is pretty much interested for many of XR use cases. Yeah, I mean, so there is a work already going on in the MPEG, and InterDigital is also basically interested in supporting this viewport-based requests. Yeah, and storing this, basically they're storing the content to support like partial access of the data.
Yeah.
Style-based and region-based thing.
Yeah.
So
yeah, I mean, my one question would be whether MPEG would be better to just define what a viewport is and what a region is, like those definitions, as and then
yes.
we would just send that. But I mean, like I said, I want to make sure that they have the right expertise to do those definitions, to make sure that you have the coordinates, and like for AR, how do you anchor it to the real world and things like that. So.
Yes. Actually, the viewport and other stuff is like defined in the MPEG, and so we were using those.
Okay, yeah. So if they're defining that, and that's just copying. I haven't actually read your draft. I'm sorry.
Yeah,
so.
Yeah. The FCI is basically constructed based on those messages.
Great.
Those definitions. Sorry.
Yeah. Mo, you raised your hand.
Yeah, I was just wondering about the quick scan of the draft. You were talking about coordinate systems that are in meters and floating point. Is that really the model in V3C that the video is described in meters and floating point in a global world coordinate system, or it's not traditional pixel based or voxel based references that are independent of any real world coordinates?
So it is basically when we make the 3D regions, yes, it is based on the points. If you can see it in the first slide itself, it is based on the dimensions. But yeah, when you say that viewport is basically, you can also send it like on the real-time coordinates. In the real-time scenario where basically the distance from the current user positions and other stuff. So the viewports can be requested in that fashion.
It just seemed a little odd to me that it didn't seem very interoperable to have some concepts of world geometry and end users physical geometry being in these messages when the video itself is not in terms of that geometry. It seemed like a more interoperable way to be relative to the actual video's dimensions, natural dimensions, not some observers' physical real world dimensions, which would be difficult to interoperate with.
Yeah, so basically it is the transmitter or sender basically converts those viewport information related to the 3D objects. So it's basically the sender translates that information into the coordinates for the spatial, and the immersive media content spatial regions.
I'll dig into V3C a little bit more and understand this nuance. It doesn't seem like the right way to specify things to me, because if you just look at a 2D analogy with video, clearly this would have relevance to image or video as well. If you just specify an ROI and pixel-based coordinates of images or videos, that would also be useful. But I would never imagine doing that from some real user observed metric. I wouldn't try to understand the viewer's physical environment and have him specify RGB feedback messages based on that physical environment I would make it relative to the actual video itself, which has, internal dimensions. It has internal dimensions of pixels or something like that. That's what I thought would be a more interoperable format
Okay.
for these messages.
Yeah. So if you see the region of interest, so basically it is based on the pixels. It's not based on the meters or something. So the regions were well defined in the SDP based on the pixels, and they were actually transmitted to the receiver, and the receiver basically understands and what kind of pixels, what kind of data it requires, how many pixels it requires. So it basically requests based on the dimensions. So that's the thing. So when in case of viewport, it is translated into those, and then it will just send back like, okay, this is what is required, this many pixels from so and so XYZ position to the so and so XYZ position, I need it, and that is translated at the server side, and then it basically understands, constructs the tiles, and then sends that corresponding content as a special region. So that's how the understanding. So if it is a region of interest based, it is just a direct message.
Okay. So maybe a little bit of wordsmithing on the draft, the difference between the message formats for the
Yep.
positions versus the viewports. It wasn't
Yep.
clear to me. It looked like they were all 4-byte, 32-bit floats in meters in a global reference system, in the global, coordinate reference system. That's what was confusing.
Okay. Sorry. Yeah, it was actually, thanks for thing. It was basically for the viewport we provided, but in case of 3D spatial regions, it's normal. It's basically the pixels. Yeah. Maybe
Okay.
I can recheck, and if there is anything, I can update it. Yeah.
Yeah, please check that and just clarify that it's integers.
Sure.
And it's in integer pixels relative to the video itself.
Yeah, sure. Yeah, it's our regions are based on the pixels actually. Yeah. Sure. Thank you.
Thanks.
All right. Any other comments on this? All right. In that case, oops. Oh, I think this slide is a dead filler. What do we need this slide?
Do we have any
So-
action items or things to follow up on?
Believe he's just soliciting comments for future development as as an individual submission draft.
Yeah.
All right. So if you have comments, follow up on the list, I guess. In which case, is that everything? I think that's. Do you have any more slides, Bernard?
No, I think that's the end of the slides. Just if there are action items on other action items on other drafts. I guess for Skip, we'll await your submission of the new draft, Daniel and Michael, and see how the ISG reacts. What will probably happen is that ISG members may drop their discusses or change their votes. And then we'll see what discusses are left.
Draft out next week. The update.
Yeah.
Okay.
Great.
Okay, I think that's it for today. We'll see you all at IETF 116.
All right. Have a good rest of your day, everybody.